Hi guys, it's Zach from the High Performance Academy here. Welcome along to today's online Gold Members webinar. Really great to have you with us. We've got a fun wiring webinar today. Well, I say fun, it's fun for me. We're going to be going through a couple of really common crimping situations, and I'm going to show you how we can use a low-cost general purpose $30 crimp tool for three different really common applications you're going to find both in the automotive aftermarket and actually the OEM world. I've chosen a couple of examples. We're going to go through crimping an AMP Super Seal 1.0 connector, a TE multi-lock connector, and a TE Econo Seal connector. Those are two really common connectors that you find in OEM applications. Particularly these are going to be used for our FD3S RX7 project, and that's actually why I've chosen them, as I need to go through and figure out what size dies I'm going to use in the crimp tool to do the operation. So I thought we'd do that on camera and get it all documented, so there's no excuses for any mistakes down the line. So we're going to jump straight into this here, and I want to have a talk about the tool we're going to use. I'll get this under our iPhone camera here so we can have a little bit of a closer look and just get some good lighting on that. There we go. Now, this is a general purpose crimp tool, and it's called so because it's got multiple die sizes that you use depending on the size of terminal and wire that you're going to crimp. It's also got two different styles of die, so if I get this angled right, we can see we've got these dies along the top here all have a, currently it's an upside down W shape to them, and we're going to use those dies for crimping the open barrel section of our terminal that makes the actual electrical connection to our copper conductor strands. And the dies down the bottom here are round section dies, and we're going to use those for crimping the open barrel conductor section that is going to provide strain relief and make contact with the actual insulation of our wire. That being said, you don't always use these round section dies for that purpose. Sometimes you do use the open barrel dies, the W-shaped ones up the top here, and we'll go through how to figure out that. Right now, in fact, because we're going to jump straight into our first terminal, which is going to be our multi-lock connector terminal here. So I'll get one of these just under our iPhone camera again, and we'll have a bit of a detailed look at what we've got going on. So you can see we've got just try and get that in focus there we go. We've got two different open barrel crimp sections here. We've got the front section, which is a wee bit smaller, and that is the section we crimp down that actually makes contact with the bared electrical conductor strands of our wire. And then at the back here we've got a larger section that we crimp down onto the insulation of our wire, and that provides really good strain relief and means any bending that happens in the wire doesn't place any strain on the actual crimped join. I'm just going to grab one other connector out here and show you another difference. So both of these terminals here are actually for multi-lock connectors, but you're going to see once I get them situated and under our iPhone camera here again, hopefully that's coming up reasonably clear, that they've got very different open barrel sizes where they're actually going to crimp down onto our copper conductor strands of our wire. Let's try and get that to actually focus in there. Yeah, there we go. So you can see those are actually quite different sizes, and this is really common when you're searching for terminals for OEM connectors. Most of the time they're going to have at least two different sizes. Typically they'll come in a smaller size that will be suitable for 24 to 20 gauge wires, and a larger size that's going to be suitable for 18 and 16 gauge wires. The situation we're going to be working with in our RX7 project, I'm actually going to be crimping an 18 gauge wire to this, so I'm going to select that larger terminal and just put the smaller one away and try to not get those mixed up and confused. So getting into the actual crimping process, the first thing we're going to need to do is strip back a section of the insulation of our wire. Now, the length of insulation that we want to strip is actually really important, and you determine it by looking at the length of this open barrel crimp section that's going to make contact with the copper conductor strands, and you need the stripped section of insulation to bear enough conductor strands that it's going to protrude all the way through that open barrel section. You need to be able to see it on both sides so you can ensure that the crimp has been successful, and it's going, you've got full contact for the best electrical continuity possible. So I'll strip a section of this back now, and just pop over to that cell phone camera again, and you can see when I get things framed up and focused. Let's try and move this over here a little bit. You can see I've bared enough copper conductor there that it is definitely protruding all the way through that open barrel section, and the larger open barrel section is still going to meet up nicely with our insulation. So once you get to this stage, you then need to determine which of the multiple die sizes in our tool here you're going to use. And it would be really, really nice if there was some magical chart that you could go to that would list every connector you're going to find and every tool and what size die you're going to use. Now, unfortunately, that list doesn't exist, and it does mean we do need to do a little bit of trial and error. You're probably going to have to perform a few test crimps to get the best result and get something that you know is going to be reliable and you're willing to put your name on when it goes out the door. In the absolute ideal world, and if we were working in a production environment, this is absolutely how we'd do it. There is a manufacturer specified tool for this operation, and we would have the correct manufacturer specified tool for every crimp terminal we were working with. However, those tools can cost several $100s, and if you needed 20 of them, you can see that things get very, very expensive very quickly. We have found that there is sufficient crossover between them that using some good quality general purpose tools, we can cover the entire range and still get a really professional and reliable result, particularly when we're building harnesses in more of a one-off fashion for individual projects. So when it comes to determining the die size, I'm going to try and do this under our iPhone camera again, as we do need to have a little bit of, you need to sort of be able to see it here. So what I like to do is line the crimp section up and, sorry, I'm just going to work around my fat fingers here. Line the crimp section up, and you want it so that when you, that's actually going to be too small, you want it so that when you close the terminal onto the tool, it just touches and there's a little bit of resistance, and it actually is going to hold that terminal in place. So to start off with here, we're going to try that C-size die, as it's actually looking like a pretty good size. So we'll get that in our tool, and we're going to get our wire inserted in there, get everything lined up, and just pop back over to that cell phone camera once more. And you can see I've got my wire inserted in there. There's no copper conductor strands poking out the side. That's really, really important, as we need for all the strands to head through that section there. And then we can apply pressure to the handles and complete our crimp operation. So just on that cell phone camera again, we'll have a close-up look and see how that has worked out there. So we can see it's folded those tangs of our open barrel crimp joint over quite nicely, and it does actually look really, really tidy. It's given us a little bell mouth at the end here, which is nice, so that's really good strain relief. So initially that looks pretty successful. What we do then is we actually do a tug test, and that just is we simply hold the terminal and pull on the wire, and you need to put quite a bit of force behind this, as you want to be sure that it's absolutely going to stay in place when we're out in the field. So we'll do that now, and we'll get a bit of force on that, and that is a failure. Right, so that's one of the situations where this really looked like it was actually going to be a success. I had high hopes for that. That larger die size, everything looked really, really tidy once it was crimped. It looked nice and tight, but that didn't take too much force to pull out of there, so that has actually failed. So we're just going to trim another bit of wire off, get another appropriately sized multi-lock terminal, and I'm going to insert this into our tool. This time we're going to choose the D-size die, which is the next size down. And just leave that set up there while I strip another wee section of insulation off our wire. And I'll try and get this onto the overhead shot here. So we can see I'll get my wire inserted into my terminal, and everything is lined up. I've got no copper conductor strands out the side there, and I can apply pressure, and that actually felt quite good. So we'll pop over to that detail shot again. And you can see there that once again that looks really, really nice. We've got a nicely even folded over open barrel section here. We've got our little bell mouth. We've got our copper conductor strands poking through, completely visible, so we know we've got full contact on our copper. And undertaking that tug test again, I can really put quite a lot of force on that, and it's not budging whatsoever. So I know that is going to be a totally successful crimp join, and it's going to be really solid once we're actually out in the field. Once we get to this stage, we've made our open barrel conductor crimp that is making connection to our copper conductor strand. So we've got electrical continuity now, but we need to crimp our strain relief section here, as that's really important because it means when this is inserted into our connector body, any bending strain that's placed on the wire is going to be taken up by the insulation and not by the point right where that crimp joint actually joins the copper conductor strands, which eventually would work, harden and fracture. So it is a very similar situation to the one we've just been through. It's a little bit of a trial and error process. We're going to use the same tool for this, and I think because there is a general rule of thumb I go with, and that is when I come to crimp the insulation section of the open barrel conductor, I will step up one die size from where I crimped the conductor portion of the open barrel conductor. So we'll pop up to the C section die here, and get that all lined up in place, apply a bit of pressure, and get that out of our tool, and that has definitely crimped over quite nicely. Popping back over to our detail shot once more, get that framed up, and we can see that I've used our C size die to fold over those upper tangs. And right at the beginning of the video I did mention that we will often use the round section dies of our multi-purpose tool to do this. This is actually a terminal where we don't do that. We use the W-shaped open barrel crimp tool because these tangs were quite long and they were directly in line with one another. So if we tried to bend them round with that round section die tool, they would have butted into one another and we would have had a failed crimp. But those are making good contact with our insulation there, and they're going to be providing really good strain relief. So that's going to be a nice, reliable crimp that'll be good for the life of the vehicle. Actually, there is one other point I want to mention there, and it involves the connector body. Obviously, this is the last part of the process you're going to do, is going to be terminating this into our connector body, and you need to make sure that when you've crimped the insulation section of your open barrel crimp, that the crimp is narrow enough that this can actually fit into your connector body. So if I go ahead and try and pin this in now, we can see it does in fact fit all the way in there, and that's held in by the locking key now, and we can actually lock that in place, and that wire is not going to move anywhere. So that's going to be a really good successful crimp join that's going to be good for the life of the vehicle. The next demonstration I have for you today is very similar. There are a couple of differences though. We're going to use, it's based on an TE EconoSeal connector, and it's also an open barrel crimp connector, but it includes an integrated wire seal. So this is my wee bag of connector supplies here. So I'll pull one of these out, and I've actually got two bags of these connectors again, because once again it's the same story. There's two different sizes of them depending on the wire size you're going to use. In this instance, I know that when I build the wiring harness I'm going to be crimping 22 gauge wire to it, so I've chosen that smaller size of terminal. So I'll just get all my bits and pieces sorted out here, and then we'll have a talk about all the individual pieces of the project. So the main difference is actually going to be the wire seal. So I'll just pop that on the end of my tool, and we'll head over to our cell phone camera again and have a talk about how they work. So this is what's known as a single wire seal, often called an integrated wire seal, and it gets installed onto the wire. Try and get that, there we go. Gets installed onto the wire, and then when the terminal gets crimped onto the wire, obviously the first open barrel crimp section needs to make electrical connection with our stripped conductors, but the strain relief crimp section actually crimps around that portion of our single wire seal, and this holds it in place, connects it to the terminal body, and then when it gets inserted into the when it gets inserted into the connector body, the ribs up here actually seal it environmentally. So these are really commonly seen. There's a couple of different brands of connectors out there that use the same style of seals, Weatherpack being another common one used in the industry. Got my 22 gauge wire here, and the first thing I'm going to do for this is I'm actually going to install my seal in place. And you can do this before or after you strip a section of the insulation. I like to do it before, as it eliminates any chance of any errant copper conductor strands actually poking out the side of these seals. So we'll get that in there, and we need to pull it a wee way down the wire. So just being a little bit tricky. Sometimes actually a little bit of lubricant could be really handy in this situation, particularly silicon-based lubricant such as tyre shine is actually a really good one, as it's not going to affect anything electrically, it's not going to add to any corrosion, and it really does allow things to slide around nicely. So I've got my wire seal inserted down my wire a wee way, and I'm going to go ahead and strip a section of our insulation back here. So that is going to be my 22 gauge side size on my wire strippers here. Get the right amount poking through. Right, and we've got, there we go, we've stripped a section, and we've got our copper conductor strands out the end of the wire there. So then we need to slide our wire seal all the way back up to the end of our insulation, and that way when we crimp our terminal on, everything is going to line up nicely. So popping back over to our cell phone camera here, we can just see how that's going to work. You can see there that, if you could see there, that everything's going to line up, and that crimp is going to end up in exactly the right place. So now we're at the same situation again. We've got a terminal, a section of wire here. We need to connect the two, and we need to know the size die that we're going to use on our crimp tool. So I think we're going to start off once again with the D-size die. When I'm doing this, I do generally tend to start a little bit larger on the die size and work my way down, I find it a little bit easier that way. So I'm going to get that terminal inserted in our D-size die here. Going to get everything lined up in place, our copper conductor strands all the way through that open barrel crimp section, and apply pressure. And right away I can see that it has folded over our open barrel crimp section nicely, but I suspect that's probably not going to be tight enough. And popping over to our cell phone camera again, I'll go through why I think that is. So if we have a look at this, we can see that it does actually on initial inspection look quite nice. However, the width that we've ended up with here on our crimped section is actually a wee bit wider than where the terminal necks down, and that's the reason I suspect this isn't actually going to be a tight enough crimp, as I would have expected to see that being a wee bit closer to this dimension here. So we'll undertake our tug test, and yep, absolutely, definitely not going to be the right size die for this application. So we'll pop that terminal to one side, making sure that we don't mix it up with anything else. And I will get a replacement, and I will fit this into our tool. This time I'm going to move down a die size. I'm going to go to our E-size die here, which is actually the smallest this tool has. And that's fitting in there quite nicely. Get everything lined up once more. Apply pressure. And that is looking quite nice and tight now. So I can put quite a lot of force on that, and that's not moving around at all. Just on our cell phone camera once more, we'll have a quick look at that. And you can definitely see that it's crimped much tighter. The dimensions at the front here are actually, it's a nice line here, so that is definitely going to be the right size die for that operation. Now we need to crimp the larger open barrel section here, which is going to crimp down onto our wire seal. And for that we are going to use one of the round die sections on our tool here. And I'm going to start with the larger one. I definitely don't think it's going to be the smaller one here, as that's around about the size of our wire. So I think we're going to be golden with this larger die size here. Get everything lined up, which is sometimes a little bit easier said than done. Often actually just closing these up a wee bit by hand first can be really helpful. Get that all lined up, apply our pressure, and that is gripping that wire seal nice and tightly. Just on our cell phone camera again for a detailed shot of that. There we go. So you can see that's gripping onto that wire seal. We can do a little bit of a tug test actually just by getting our fingernails behind that wire seal, and you can see it's not going to move. So that is going to be a good successful crimp join that is going to be nice and reliable for the life of the vehicle. Once again, the final test is going to be how it inserts into our connector body. So just on our overhead view again here, this is a TE Econo Seal connector. So we'll get that in the back here, around the right way. Oh, nice click. So that is engaged, really nice. And then the last part of actually installing these terminals is to put the locking flange in the front here, which I'll just get in place. So that is going to be securely held in there, and it's going to be good for the life of the wiring harness. As a wee aside, you will notice that these connector bodies actually look pretty new. They're all looking pretty tidy and clean. I can tell you they did not look like that when I got them out of the engine bay. They were from an RX-7 that had leaked a lot of oil over its life, and they were just gungy and covered in grime. And a really good way to clean connector bodies like this is to get hold of an ultrasonic cleaner. Typically they're sold for cleaning jewelry. I like to use about a 50-50 mix of boiling water and simple green, and yeah, sort of half an hour to an hour in the ultrasonic cleaner, and connector bodies like this really do come up almost looking brand new. One thing you definitely have to check when you're trying to reuse any connector body is that it's still nice and pliable. The plastic hasn't gone brittle from too many heat cycles. So this one's got a good locking tab on the back here, so I know when I put this back in the vehicle it's going to hold itself onto its sensor nicely and not crack and fray away. So now we're going to get on to our final example, which is really commonly seen connector usage in the aftermarket, which is our AMP Super Seal 1.0. But just before that, we are going to have a question and answer section on sort of any automotive wiring related topics at the end of this webinar. So if you've got any of those questions, pop them through on our chat now. We are aware that the chat on our website is broken, unfortunately. Our website magician Cam is away at the moment, so we couldn't get that fixed in time for today's webinar. We'll have it fixed for next week, but pop onto our Facebook website, and we've got a live stream going there, and you'll be able to ask any questions there. The guys will pop them through to me, and we'll get those answered. So the situation I'm going to be in when I'm wiring up our RX-7 is that I'm going to be installing an ECU that has an AMP Super Seal 1.0 connector, and I'm going to need to crimp those pins onto our 22 gauge wire again. So I'm just going to snip that one off and use the same 22 gauge wire we've got here for our example. So having a look at our terminal, just going to pop back over to our cell phone camera, because there is one important difference with these terminals I really want to point out. There we go. Hopefully we can see that nice and clearly there. So we can see we've got our standard open barrel crimp section here that's going to make the connection to our conductor strands, and then our open barrel section here that is going to make the connection to our insulation is actually, these are triangle shaped and they're offset from one another. And just keep that in mind as we go through the crimping process, as it'll become very apparent why that is. So situation is the same as we've been in before. I'm going to strip a section of insulation back here on our 22 size dies. That is long enough that our open barrel, that our copper conductor strands are all the way through our open barrel section there. Looking at this, it's a very, very similar size to the example we've just done with our EconoSeal. So I'm going to head straight to our E-size die on our general purpose crimping tool here. And I'm going to get everything lined up all the way through there, nice and tidy, and apply that pressure. And straight away that looks like a pretty good crimp joint. Everything is folded over nice and evenly, and I can do a pretty firm tug test on that and nothing is moving. So that is going to be nice and reliable and tight for the life of the vehicle. Now we need to get on to the next section, which is crimping down the open barrel terminals here, the open barrel terminal onto our wire insulation. And as I mentioned, the two tanks here are offset from one another, and they're that way for a very specific reason. It's because when we crimp this down, we want to use a round die section in our crimp tool, and that means that as those two tangs fold over, they can actually overlap one another. And when you come to pin these terminals into the back of an AMP Superseal 1.0 connector, that becomes very important, as they have to fit through a round hole. So if you were to crimp this with a W-shaped open barrel crimp die, they end up being quite wide, and often you can't get them actually into the connector body. So for this situation, as I mentioned before, the smallest of the round die sections here, which is the B die, is actually around about the same size as our wire. So I suspect that's going to be the size that we're going to want to use. So I'm going to get that all lined up, apply our pressure, and there we go. That's actually looking nice and tidy. We'll pop over to our cell phone camera again and have a good look at that. We can see we've got those tangs folded over nice and tidily. They're gripping that insulation really well, and they're nice and tight and going to be giving us good strain relief. So any bending that happens is going to happen on the insulation and not further down where this crimp joint is happening, avoiding us any possible issues down the line. Now, you'll notice that I've mentioned a few times during this webinar that we're going to apply our pressure with our hands. And I've used that wording for a very specific reason, is that this isn't a ratcheting crimp tool. A lot of the crimp tools you find are ratcheting, and they're that way for a reason, and it's because once you start the crimp with a ratcheting crimp tool, you can't actually release the tool until you apply the maximum amount of pressure and finish the operation. With a tool like this, a general purpose tool, we can actually choose the amount of pressure that we want to apply. And once again, in a production environment, we're going to use a ratcheting tool because we know that it's going to be set up to provide the perfect amount of pressure every time. But in a more one-off environment, like we're often building wiring harnesses for, I find a tool like this that I can choose the amount of pressure to apply to be more valuable. And to be honest, this is probably the tool that I end up reaching for the most when I'm terminating a harness for a sort of club level race car or a modified street car. If we get into the more professional realms of motorsport, where we're using autosport connectors and closed barrel crimping, then absolutely you're going to have to use the manufacturer specified tooling, and there really is going to be no way around that. The amount of pressure you're going to apply when you're using a tool like this does come down to a little bit of practice. So one thing I would recommend is getting yourself a few lengths of wire and buying some terminals like this. The terminals I have here for EconoSeal and multi-lock connector bodies are actually very, very cheap from the likes of RS Components or DigiKey or even Element 14. So you can buy 100 of them and have a good practice, and it's really not going to cost you too much money at all. I really hope that's given you a little bit of insight into how we go through the process of selecting a crimp tool for our application, and let you know that you can get a really reliable and professional result without spending the earth. I absolutely wish that I could go back in time and take back some of the money that I've spent in crimp tools over the years, as they sit in the bottom of my toolkit now and very rarely get pulled out for the type of work I'm doing these days, which is club level race cars and modified street cars. So I really hope you've enjoyed that, and it's given you a little bit of insight into how we make that selection. So we'll going to pop over to my laptop now, and hopefully the guys are popping through a few questions for me, and we will get those answered. Craig has asked, would it be a good idea to put a dab of dielectric grease on the copper before crimping? That's actually a really good question, and it's probably going to depend on your application. The blanket answer to that would be yes, it is going to give you a little bit of extra protection. Dielectric grease by its nature is not conductive, but that's not going to be a problem because when we perform the crimping operation, it does actually end up giving us a little bit of a cold weld. When we apply that pressure with the right size die, we're actually going to deform the copper, and everything is going to end up in contact. So none of that dielectric grease is going to get trapped in there. It's going to squeeze out the side and probably give us a good barrier from any further ingress of grime, particularly for a sealed connector here like our Econo seal, probably going to be less important because we've got that wire seal doing the job. But if I was crimping onto our multi-lock connector here and this was going to be in a position where I suspect it might get dusty, then yeah, that probably is a very good idea. So absolutely go ahead and do that one. I've got a question here from YeoZ. When you're looking for a general purpose open barrel crimp, what kind of die are you looking for? In my local market, they mostly have W-shaped dies. I'll probably be working mostly on TE connectors, Super Seal / Econo Seal. Really good question, and to be honest, this tool here is probably the one I'm going to recommend that you try and find. There are 3 common tools that actually have this exact same look to them. So it's the same shape handle, same length, and same operation. I do actually have all 3 here because I anticipated we might get this question. And if we pop to our overhead camera, let's get everything out of the way. Hopefully there's enough detail on that overhead camera that we can see the difference between our tools here. So the one on my right here is for weather pack connectors, and you can see it's got our W-shaped open barrel dies and quite large round dies. The one in the middle here solely has our W-shaped open barrel crimps, and to be honest, I very, very rarely pull this one out of my toolkit, as I find almost all other applications are covered by these 2 tools here. These are available from just a myriad of online resellers. I think I got these 2 here from Motorsport Electronics here in New Zealand, but I'm sure any of the motorsport or automotive wiring suppliers are going to have them, the likes of RaceSpec Online or milspecwiring.com, for example. Got a question here from Ron. Have I ever had a question with a terminal bending at an angle between the contact pin area and the open barrel section for the copper? Sometimes this makes the terminal wavy and makes it hard to insert in the connector. This only happens with a universal tool and not factory style tools, as they have a die to hold the terminal from bending or twisting while crimping. Yes, I have absolutely had that happen, and it happens when you've selected a size die that is actually too small, and that ends up deforming the copper in such a way that it stresses that join between our larger open barrel section for the insulation and our smaller open barrel section, and they'll bend away from one another. The solution to that is you can go about it 2 ways I've found. You can step up a die size and try it there. If that's not giving you the reliability when you perform your tug test, you can step back down to that smaller size, but try applying a little bit less pressure, a little bit less hand pressure, and that should see you right in that situation. YeoZ has asked, do AMP Super Seal only work with a certain range of wire gauges? Having trouble doing shopping here. There are 2 different part numbers for AMP Super Seal connectors. One, as I mentioned, it's that common situation where one is for a smaller size wire, so that's going to be from 20 to 24 AWG, and the other is for larger size wire, which is 16 and 18 AWG. If you're working in metric units, that's going to be, the smaller sizes are going to be from 0.25 millimeter squared to, I think, 0.5 millimeter squared, and then the larger sizes are going to cover you from the larger size there, so that's 0.75 millimeter squared, I think up to 1.25 millimeter squared. The part number on the ones I have here is 3- I should get these under here because you can take a screenshot, 3-144-7221-4, and I know that they are actually the smaller size. I know that they are actually the larger size. I think the same part number but with the suffix -3 is for the smaller size, so hopefully that helps you out with your shopping. Jason has asked, when working with TFZL wire /16 or /32, I find it difficult to locate common terminals like spade or ring terminals that will actually give you a good crimp on the insulation. Do any companies such as TE, etc., have terminals that are more geared for TFZL wire? That is probably going to depend on the size of wire that you're going to be using. What you're looking for in that situation is a ring terminal that has a completely closed, encased closed barrel terminal, and by that I mean that the closed barrel section doesn't come up and it doesn't have a join. You want it to be one piece, and you're going to need to use a specific closed barrel crimper for that situation. Off the top of my head, I can't think of any brands that you're going to just be able to Google and find, but I think you're looking in the right direction at TE/AMP, as I know they do a range of ring terminals, and they are probably going to supply them to that higher level. You're going to have to be very careful with the size terminal you select, though. It is going to have to be right for the wire. Mike has asked, is there any benefit to soldering after the barrel is crimped? And the answer to that is no. There is absolutely no benefit to that whatsoever. I touched on this earlier on, was that when we perform a crimp join, we supply adequate pressure that we're actually going to deform the copper and the terminal itself, and they're essentially going to be cold welded together after the process. So you're not going to get any benefit from soldering after that. You're not going to get any better electrical connection. In fact, you're possibly going to make the situation worse, as no matter how good you are at soldering, you are going to get some solder wick back up the wire. And if it is enough, it can actually wick all the way past your strain relief crimp, and it can turn a section of the copper wire past that into what is basically a solid core wire. Then any bending strain that's going to be applied to that is going to be on that solid core section, which is going to be really subject to breaking from vibration. So no, I could never recommend soldering after crimping, as it's really not going to give you any benefit whatsoever. Craig says, does Zach make those beautiful looms you see on show cars? Well, that's a really good question. I make all different kinds of wiring looms. For a long time, actually, before I came to work at HPA, I did work on very, very high level single-seat race car wiring harnesses. So these were built with absolutely no limit to the budget. So it was all the best gear, all the best tooling. Everything was specified and designed to within an inch of its life. Concentrically twisted, just beautiful wiring harnesses, and that may sound like it is a dream job to anyone that likes working with wiring harnesses, and I can tell you that for a while it absolutely is. But my main love is actually the modified street car and the club day track car genre. So coming to work for HPA was a really good fit in that respect, as it's allowed me to create courses that cross over a lot of my professional motorsport knowledge into more achievable realms for the people working on a club day track car or their modified street car, with the aim of just getting a really aesthetically pleasing and totally solid and reliable result, as chasing down wiring gremlins on a modified road car is definitely one of my most hated things. It can cost you so much money when you've actually got the car up and running on the dyno and something goes wrong, so we really need to avoid that. It looks like that has actually brought us to the end of our questions there, so that's going to be the end of our webinar today. I really hope you've enjoyed it. Wiring can be a little bit of a dry topic. It's quite difficult to come up with a webinar that is going to be visually appealing and keep people engaged, but I think the information that we're trying to get across here is really, really important. The key being that with some good quality general purpose tools, you're not going to have to spend absolute megabucks on the factory recommended tooling to get the job done. For getting the job done for a club day track car or a modified street car, these are going to be absolutely perfect, and they're not going to cost you the earth, and you're definitely going to come out a winner over paying someone else to do the job for you. So thanks heaps for coming along to today's webinar, guys. I really hope you've enjoyed it, and we hope to see you on the next one.
It's just a taste of what we put on every week for our HPA Gold members. We've currently got over 240 hours of existing webinar content covering topics on engine building, engine tuning and wiring. Click the link in the description to learn more.